Very good afternoon to all the students of computer architecture. We are going to learn this PTE 3213 computer architecture in a very short moment. So I believe I've seen about 25 students here already. Yeah, there's still 6 haven't come yet. But we usually we start in 5 minutes. For example, 2:05. So welcome to the class again. So this is our second week's lectures. So today we are going to study our next chapters, which is the chapters number 2. So for last lectures, we already learned many things. For example, we learned what is inside a computer and also the performance of particular computers. How do we measure using Amstel law, and also we are going to use the CPU performance formulas to calculate that. So for today, we are going to move into the second lectures, which is the instruction set architecture. So as all of you know, instruction sets are very important in a computers. Why I say so? Why did I say so? Because without the instructions, you won't be able to design the programs that are needed for any of the applications. So for today's lectures, we will use about 2 hours to discuss about these instruction sets. Later, I will also show you some of the examples of the assembly codes that you will see in many processes. So basically, what is this instruction set? Let us start our lectures. So before that, do you have any questions want to ask me before I start my lectures? Anyone has any question? Boon Kyung, any question? Because Boon Kyung name is B, right? Starting from B, yeah? So I always see his name first. Noah? Okay, good. So we still have another 5 or 6 students that haven't come. Okay, no question. Okay, good. Let us start. Yeah, I don't want to waste a lot of time. There are about 21 slides in these lecture notes. For your information, we have how many chapters? 9 chapters here. So on week 1, we have already done the chapter number 1. And then week 2, after that, we will do these 9 chapters. We have about 5 tutorials. So I think we are just in time to finish our lectures before the week 14. Okay, now let's go into this instruction set. What is the instruction set? What is the instruction set? For electrical engineer, even though you are mainly focused on the electrical design, so you must also know a little bit about software, especially for the electronic stream. So when you see this instruction, so what is this instruction? This is basically the assembly code, assembly language, right? Assembly code. Okay, for the X0, X6. Of course, this includes Pentium, i3, Pentium 4, X6, and etc. Okay, all these, etc. So today we are going to learn about the instruction set, principles, and examples. If let's say in future you become the computer architect, or in future you work in companies like Intel, or Huawei, or any other companies like Microsoft. Even though you work with Microsoft, you still need to know assembly language because they want to design the software for the users. Without assembly language, you cannot design many of the software. So for this chapter 2, we are going to talk about this instruction set, principles, and examples. We have 24 pages. So what is instructions set architecture? In short, it has the short form of ISA. So we have the ISA instruction set architecture. So we want to classify the ISA. Then we also want to know the elements of ISA. To classify ISA, what type of instruction set do we have? So later we'll see. And so elements of the ISA, we have this memory addressing. We want to learn about memory addressing. We want to learn about types and size of the operands. And also we want to know the addressing modes. And we want to learn about the types of operations. And also how do we encode the instruction set. Okay, for example, for the example that I have already let you see just now, move AH2. Okay, what is this? Okay, this is actually, let's say if I have this assembly code, there are actually three parts of it. The first part, we call it type of operation. Okay, type operation is the first portion, is the type operation. This one we call it opcode. Okay, so this is to talk about the type operation. There are many operations which we will learn later. And the second one is actually the register. In Intel X0, X66, there are many registers. We have many registers. This one is the A registers. Okay, so this is about the type and size of operand. For the AH, we have about 8 bits. 8 bits. I know all of you know about these 8 bits. Okay, we have 8 bits. Later, I will tell you how to tell that whether it's 8 bits or 16 bits or 32 bits. Okay, and even though now we have the 64 bits for our new computers. And then the last one is the addressing modes. Okay, for this one, the addressing modes is basically immediate. Okay, immediate. Later, I will show you one by one. And for the AH, what is the addressing mode? It's actually register, because AH is a register. But whereas the 2 is actually a number, which point to the immediate mode. And then encode of the instruction set. Okay, encode of the instruction set means for this move, it cannot be represented in the computers, right? Because computer is all about the logic gates. So now we have to code it like 1100 and then AH. Maybe we use another one, 1001 and then 2. Maybe use another one, 0010 to represent the 2. So this is actually the encode of the instruction. And this instruction, we call it machine code. Okay, machine code. This machine code is to use to represent the assembly code. So this is called the assembly code. So this is the structure of a computer instruction set architecture. Any question you have before I continue? If no question, then I shall start. This is just the outline. So why do we need to design different set of instructions for different type of the computers? For example, for X0, X66, it has its own instruction. But for ARM, it also has its own instructions because the computers are designed for different application area. Okay, for desktop computing, for example, let's say if you design for the desktop computing like what has been done for the Intel Pentium. Intel Pentium is a family or is a computer in the X0, X6 family. These are all the Intel computers. This desktop computing emphasizes the performance of the programs. There are some data types and also integers as well. So they have very little regards for the program size because for our computer, we have basically, if you buy a laptop, for example, right now, many people want to buy laptops. I believe because all our primary school, secondary school students all wants to buy laptops now, because now throughout the country we are using the online learning, right? And then that's the reason why if now you go out and want to buy a laptop, you have to wait for the normal spec laptop. You have to wait like 2 months before you can buy it. Okay, but all those laptops minimum you will have like 256, right, gigabyte. Sorry, 256 gigabyte. 256. Sorry, 256 gigabyte to 1 terabyte. Of course, some will get 2 terabytes. That one is a high-end one. Okay, normal you will only get this 256 gigabyte to 1 terabyte. That's why memory is not an issue for the Intel Pentium computers in terms of the hard disk. So they have very little regards on the program size and also the processor power, because the computer is plugged into the socket. So at home, they have no problems. Okay, so second applications area is actually the server. Okay, what is the server? The server is basically a computer that is used to do some specific job, like the network server and also data server. The job is just to handle the database file server like Facebook server or web server. Okay, so in this case, the floating point performance is less important. So all these servers have different types of processors. Okay, they have servers processor. They have specific processor for that. Yeah. After that, we also have the embedded applications. What is this embedded? Yeah, this one is related to your handphone, smartphone. Now we call it smartphone because it's very smart. Why we call it smartphone? Because it starts from Apple, right? Apple iPhone. Yeah, because they found that it's very smart, so they call it smartphone. Yeah. So embedded application also include all other things like many things. Washing machine. Also may have some computers inside, or any other devices like your TV box. For example, now many people have TV box at home. So this one is also embedded applications. Even though it's not like a computer, but you can have a computer inside. So the code size is very important. Why? Because for your handphone, because most of us don't have the money to buy very, very high memory handphone, right? We only some only get 8 gig. So that's why the memory because less memory is cheaper and lower power. So last one will be the DSP processor and also media processors. These are some of the processors that can be used in the embedded applications or inside the computers. Usually, they are used for some key kernels. Key kernels means, for example, let's say if your computer application always use some specific function, for example, video processing. For example, you always do the video processing. You want to do image recognition, example, everything, image. So you might need a processor. We call it core processor. So that this core processor will handle all those heavy calculations instructions. So this is all 4 types of the applications area that you might want to involve. That the computer need to handle. Okay, what is the ISA? Instruction set architecture is something very, very important. We want to design how many instructions that we need for our computers. Okay, so this one is inside the computer. It's very visible to the assembler language programmers or the compiler writers. That means this is very important for all the programmers. For example, let's say in future, you want to work as inside the computing companies. then you must know this assembly language. Because this is how the computer actually read the instructions. So what is inside the ISA? The ISA actually include the programming registers. For Intel, we have the A, X, B, X, BX, and then CX and DX. Basically, these are all the Intel, Intel registers. There are many more. Later, I will show you one by one. So we have AX. And then this AX, they have split into two because this AX is 16 bits. Split into two, AH and also AL. So this one is actually the high, and this is the low. You might have the question, since now our computer is more than 32 bits, how to get the 32 bits? In order to get the 32 bits, they have the EAX. So later we will learn EAX. AX is 32 bits. They also have the 64 bits registers. Later we will see. But that one a lot difficult already. So we have the programming registers. Then we have the operand access. Operand access means you can access to memory, or you can access to the registers. Third one is the type and size of operands. This one later we will see. And then we have the instruction set. We need how many type of instructions, also the addressing mode, and also the instruction encoding. This one is about the machine code. From the machine code, then only we can have the assembly code, then only can have the C programming or Java programming that you like. Because all the Java and the C programming eventually have to come to machine code. If not, then computer cannot understand. So this is how the computer works. So we want to classify what type of instruction set architecture do we have. There are three types in terms of the way they're designed. This comes to the story. Let me tell you a little bit about the story of the first computer that has been invented. This is the name of the first computer invented. It was started around 1940, 41 or 42, 1 or 42. Around that time, the engineers start to construct the computers. For what purpose? Can you guess? Anyone can guess what the purpose for this computer? ENIAC. Anyone? Also, for research? No. Yeah, for research, yes, but for specific purpose. What do you say? What do you say? One Hanxiang. Let me see. So Yan Shang said make calculator. Yeah, maybe, but for some purpose. Hanxiang, World War II. Yeah, correct. You're right. Hanxiang, correct. It's for the World War II. Because that time, they want to do many calculations for the weapon. For example, we have many weapons. So they need a very powerful computer to calculate. But the computer cannot be, because the World War ended 1945, right? ENIAC is after that, about 46, 47. So about this time only, it has been successfully created. At that time, the World War II is already finished. So they cannot use it to calculate any weapons. But the ENIAC has been used to design hydrogen bomb, which is unfortunately design hydrogen bomb. Something even more dangerous than the atom bomb. So that's the usage for the first computer. But after that, it has become the personal computers, so for the good use. But initially, it was designed for the World War II. Yeah, correct. Answer correct. So very good. You figure out what's the answer. Very good. Now let's see what is the architecture. So the first computer that has been invented, basically they use the stack architecture. What is the stack? The stack is basically like this. Stack is the last in, first out. Okay, architecture. So when you enter, you put the things here. I say A, B, C, D, E. So this is called a stack. Okay, stack memory. Okay, so at first the computer are designed so that operands are implicitly on the top of the stack. So whenever you want to do some operation, then they do it using the stack. Okay, after that, they found that the stack is not very flexible in manipulate some of the data. So what they do, they create some other architecture called accumulator. Accumulator is just a one register, okay, accumulator. The name is ACC. So everything is, all the operation is done based on this ACC, meaning, let's say I put a 5 here. So now I say add 6. What will happen? Then my ACC will become 11 ACC. Okay, so this is the ACC accumulator because it accumulates everything. Let's say here I say delete 1. So accumulator will become 10. Okay, so this is the accumulator. So this is before the Intel about roughly after the between 50 to 70 years. Okay, 1950 to 70 years, they use the accumulator architectures. So only one operand. Everything done on this accumulator. Now we have the general purpose register architecture. Okay, so until now only we can see the from 1970 something, we see the general purpose register architecture. Means we have more than one register. Register means we have 1, 2, 3, 4. Let's say we have at least 4. Now we have the AX, BX, CX, and this. Okay, for the Intel. So these Intel registers only for explicit operands, either register or memory location. So we have the register memory and also register. Means that you can actually access memory as part of any instruction. Means that if I have some, let's say I do like this, I move AH 1111, for example. What's the meaning of that? Is that I can access through the memory location here. Memory location. Okay, so I will move the content inside this memory location to my AH. This is what is meant by this instruction for the Intel. So we also can have the register to register instruction. Let's say I move. You know move, right? AH, BL. I can move the 8-bit data from BL to AH using this instruction for Intel X0, X6 instruction. So after the Intel X06, okay, the first Intel personal computers invented, then we have the general purpose register architecture. Of course, there are some computers using this before that. Okay, roughly that time. Okay. So now I'm going to discuss to you, explain to you what are the stack, accumulator, register, memory, and register. Okay, so now let me change the color on my pen. Don't worry, I will give you some rest time at the middle, about 15 minutes by 3 o'clock. Before 3 o'clock, I will give you 15 minutes rest. So we have the, what is this? What's this symbol? Very strange, right? This symbol is actually ALU. Okay, ALU, arithmetic logic unit, ALU. Okay, so for the stack, for the first generation of computers, they use the stack. This is the top of the stack. So the ALU always use the top of the stack. This is TOS is top of stack. First top of stack, and this one is actually TOS minus 1 or plus 1, depends on the addressing modes. So now, whatever you do, you can only do towards these two, okay, these two stack components. Okay, let's say this is 5. This is 6. So if I do the add operation, let's say I do an add operation, what will happen is, after I've done, then I will have to store data 11, store to here. So 6 will disappear. Okay, so this is what is meant by this stack. So for accumulator, every time I have to move to this accumulator, yeah, I will perform the function based using this computer. So this accumulator. So let's say I have a 6 here. This is 5. So I have to move the 6 from the memory to the ALU. Then from here I transfer to here. So only after that, this one will become 11. So the last two. For register memory, I have to move the memory to the ALU. After that, I move to all these register. Okay, I move register. Let's say here. So only then I will do the operation and store it back. So this is for register memory. For register, I only do the operation based on the register only. So I can get this one, AL, BL, and then I store at the CL, like this. Okay, so these are the some of the ISA classes: stack, accumulator, registered memory, and register. Okay, let's look at this code sequence. How do you do this? So for the stack, let me first I push a stack here. Okay, I push a stack here. This is a stack. Okay, what is this instruction stack? Okay, I push A. Do you know the push? I push the one things inside the A. Okay, now what it does? I push the A. So at the bottom of my basket, you can imagine the stack is a basket. I push A into the basket. So at the bottom of the basket now, I have A, right? I've done with the first one. Then I push B. Then I push off. A is at the bottom, B at the top of the stack. TOS is now here. Top of stack. Now I do the operation add. What will happen? Yeah. Okay. For those who learn a lot about computers, that you know. So from here, let me go here better. Okay. So if I do the add operation, so this is what will happen. At the bottom of the basket or stack, I have the A plus B. Okay, so this will be 11. Let's say this is 5, 6, then this one will be 11. Okay, that pop C. Pop, you push already, now you pop. So this C will be pop out. Okay, pop out. So eventually after I pop, so my basket empty again, empty, nothing. So after I pop the C, I pop to the C. Okay, C is either a memory location or any other places. I pop it. So I've done the operation carefully. So second one. Okay, any question about stack? Anyone has any question about stack? Later you have to do the tutorial about the stack. Any question? If not, then I go to the accumulator. Now accumulator, load A. Load A. This is, I only have one accumulator. Load A. I put A here. Then add B. What will happen if I do the second operation? So now I have to erase the A. Okay, A is no longer there. Why? Because accumulator become A added to B. And then I store C. Store C means I put this A and B, I store into the memory. I have a memory. And then at this location, C location, I put the A plus B here. So this is store C. Means the data in accumulator is stored into C. Usually the data still remain there for the accumulator. Yeah, unless you clear it. Okay, now the last this one is load the R1 become A. So means that, let me erase the, the ink first. Okay, for this third one, for the load RA. So RA is a register. You load A into the RA. So put A here. Okay. Add the R3, R1, B. So you have another register. R1, R1 add to RB. R1 added to B. Okay. Store into the register 3. After that, store C, R3 means the C location is a memory location. We store the content of the R1 plus B. Yeah. So this is how it does. Okay. Yeah. The rest will be the same. Load store also same. This one we will do the exercise after that. So this is about the ISA architecture. These are some types. Any question you have before we continue? Any question? Missile projection. Yeah, now computer is used for everything. Yeah, including creating vaccine for our pandemic also. Yeah, that depends on the person. If the person who use that tool is good, then he can create some good use. If not, if you fall into some people with some bad purpose, then it's very dangerous. Yeah. So, truly, yes. Okay, now, any question before we move on? If not, then I move on. Yeah. Just finish it. Okay, now we development of the instruction set architecture. So you know that early computer actually used the stack accumulator architecture. Okay, because it's easy to build, and then you can just now you can see how we did the stack operation, right? Later in tutorial you also have to do. Yeah. Okay. Now general purpose register architecture dominate from 1975. So X0, X6, X6 about 78. This one about 70X. Intel first personal computer. Because register are actually faster than the memory. Memory you need to is outside of the CPU. Register is inside the CPU. So registers are easy for a compiler to use. So you can hold the variables. That's why currently all our computers have a lot of registers, including your handphone. So for the registers, generally we have a lot of registers. Those registers we call it programming register. Okay, all the general registers should be orthogonal, means you can use for any purpose. Any purpose also can. Okay, let's say I have AL, BL, CL, DL. All these 4L. Ideally, I can use BL for adding, also for CL for addition, also DL also I want to use it for addition. But in reality, your instruction set will limit your usage. They say when you add this to this, you cannot add DL, you can only add BL and CL. They will make it like this because in the circuitry, they don't decide so many things. Yeah. So for orthogonal, it's very difficult to implement because you need a lot of logic, a lot of digital circuit inside. So we will see how many resistors are inside some of the computers. When you hear about PDP, anyone heard about PDP before? I don't think you all have used this before, because I think you have not born yet. I also haven't born yet, I think. Yeah. So PDP-11 is a series of 16-bit mini computers, or sometimes 8. And then, okay, it's having 8 registers. Some are reserved. We have some register, we call it PC and SP. So these are two very important register. PC. What is the name of PC? Program counter. If you do microprocessor, then you learn this before. SP is actually stack pointer. It's a top of stack. Okay, stack pointer. Yeah. So these are some of the registers, which is not general purpose. is a special purpose register just to handle something. Program counter is to point to the current instruction in your memory. So then we have the VAX VX11-780. It's a super mini computer. We have 16 registers for this VAX. Okay, some are reserved. Like this one is 13 point, like you're not mistaken, 13 point register. Enough left to keep some variable in registers. And then we also have the RISC. RISC is the one that is a favorite, right? RISC. Yeah. Why is this favorite? Because it is used to create this handphone. It's used as a component of the handphone. It can keep many variables in the registers. RISC processor has many registers. Okay, there are many, so it's very, very helpful. So now, let us see how many operands are there. You can have like SPARC, SPARC, called the Scalable Processor Architecture. So this, and also mixed processor. Also HPPA processor, PowerPC, Alpha, also ARM. So I think you have not heard about all of them, right? Yeah, except one, I know you heard about this, ARM. ARM processor is the current one. ARM and also Intel processor. These are two processors that you will always see. Okay, ARM processor is inside your handphone and also of the many of your devices like TV box. And then we also have the Intel X0x86. This one is the computer laptop that you use. Mostly you use X0x86. Yeah, you will use this model, but not Intel, maybe not Intel. Some of you, you like the AMD, right? Because the price is cheaper. Yeah, a bit cheaper. And then sometimes the performance for the graphic calculation is a bit better according to the manual. Yeah, so after that, we Motorola 68000 also, I think you haven't heard about this, but it has been very famous 20 years ago. And then TMS, Texas Instrument TMS 3220C54. Okay, so this one I think you never heard before. But all these computers here, the processors here, they use maximum number of operands is 3. Okay, then here, they use the number of memory address is 1, 2 for the operands. Yeah. So these are some of the computers there. And then, why do we want to use only register? Because for register, it's very simple and also very fast. Okay, simple. But why do we want to use the? Why don't we use the register? Because it's higher instruction count. If you use the register, then you cannot access to the memory using one instruction. So you have to use the extra load or store instruction. So it will be higher instruction count. For the register memory, data can be accessed without loading first. So you can have a register and memory together. So source operand is destroyed in a primary operation. Okay. The third one is the memory. Mostly memory only. They don't use register, so it's very compact. You can direct access to the memory, but it's very slow memory bottleneck. Yeah. So these are some of the addressing modes that you can use. We have the constant like 2 is a constant. Register, we have the AH is the register. Memory location is like this 1100, and IO addresses this one interrupt. Yeah. So all these addressing modes can be used, and we have the memory addressing. For your information, 1 byte is equals to 8 bits, and the 4 bytes equals to 32 bits. So this is how it works. Now our computer is either 32 bits or 64 bits. Yeah, mostly at your laptop. Okay, let me continue to explain about the addressing modes. we have the addressing mode like this. You have to add R4, R3. So this is actually a register. Okay, register, and also R4 is a register. So this is called like immediate. It's a number, immediate mode. Yeah. How about this displacement? When you see this instruction, what does it mean? In your Intel, when you have the 100 bracket R1, the meaning is you will go to the memory location of 100 plus the content of your R1. Yeah. So they will go to memory and then get the data and then put into R4. Okay. Then this one, R1, what is this? Without 100. R1 is the memory location. Yeah. When you have the bracket, over bracket here is memory location. Remember. What is this? Memory location of this address. Yeah. Memory location. And then for the direct, let's say I just bracket here, I put a number here. So I direct go to memory and get the data. One very important thing is this one, memory indirect. What is this? Okay, this one means I go to the memory, get something, get the data, then that one is the address, and then I point to another memory. Okay, then we also have the auto increment, auto decrement. So these all are self-explanatory. You can read yourself. And then also have the skill one. Skill one is they have the over bracket and also rectangular bracket. So this is how it works. It's a skill one for the arrays. Yeah. Any question before I continue? I just continue. Okay, so these are the summary of the addressing modes. We have the direct, indirect, immediate, displacement. Okay, all these are the addressing modes. Also, we have a lot of types of operations. For example, we have the data movement instructions like load, store, and also memory to memory move, register to register move, input, push, pop, output. We also have the arithmetic for calculation, add, subtract, etc. We also have the shift operation, logical operation, control is if operation, logical is not, and or, it's all clear set. And so we have a subroutine, call, and return. System one, we have some virtual memory management. Later we'll see what instructions are there. Synchronization, floating point, string, and also graphic. So for X0, X6 instruction, these are the first Intel computers. Okay, so basically it has used 22% of the instruction is actually load. A lot. If you can improve load instruction, then you can improve the performance a lot. Then we have a conditional branch, compare, store, add, and sub, move, register, call, return. So all these 10 instructions constitute 96% of all the instructions. Okay. For example, let's say if you only focus to improve this 10 instruction, then you can actually improve the performance a lot. If you improve other things, like very special instruction, it won't improve your computer at all. Or maybe a little bit, 0.0001% of your performance. Yeah. So instruction for the control flow is like the if and jump not zero, if those instructions. So now I've already talked about the instruction. Next, we are going to talk about the machine code. Just now we already talked about the assembly code, right? This is assembly. But in computer, this one cannot be read unless you move it, become some machine code. Sorry, no two, 1100, and then 0010 like this. Okay, yeah. So this is called the machine code. Machine code, yeah, let me clear first. Yeah, this is called the machine code. If you can read the machine code, then you are very strong already. You can actually see what the other people write in your computer. So this is called the opcode. Let me tell you, this is the opcode. And this is the operand. Operand. These two are the operands. So we have one opcode and two operands. Okay. So it's a balance when you include among the many register and addressing mode, add to the richness, but it will also increase your code size. Okay. So when you include an instruction set, then you use compiler. Sorry. Compiler, yeah, use a compiler. Assembler, assembler, you will convert from assembly code to the machine code. But even your C compiler will also help you to convert to the machine code instantly, okay, immediately. So these are some of the basic variations in encoding. For VNX computer, this is how they do that. Operation, address, and address. They are variable, okay. So for the computer like DLX, MIPS, and PowerPC, they have the fixed encoding. That means they use certain number like 32-bit to represent all these things. So hybrid means for Intel and IBM, they can use any type of the encoding. They can be 16-bit, they can be 32-bit. So it depends on the needs. Okay, summary of the instruction format. If you want to design the good instruction, if the code size is most important, so use the variable length instructions. So if the performance is most important, then use the fixed length instructions. Okay, so you fix it 60-bit if the So reduce the code size in RISC. So for our handphone in RISC, using RISC architecture, basically they use very small code size, so that they have more instruction but smaller code size. This one, for example, is a MIPS 16 or your ARM processors. So for the IBM, compressed code is kept in memory, ROM, and disk. So cache keep the compressed code. These are the different types of the technologies. So what is the roles of your compiler? When you learn C programming, I know many of you have already learned Java. It's a very good programming language. But Java does not use the compiler. Java use something called interpreter. For Java, it's used the interpreter. Okay. For the C, it uses the compiler. What's the difference between compiler and interpreter? For compiler, it converts to the machine code. Okay. For interpreter, they convert to the object code. Okay. Then the Java machine will go and execute this object code. But machine code can be directly by the microprocessor. Yeah. So this is the difference between Java interpreter and also what is the function of the compiler. At the front end, it converts the language to some intermediate form. Then after that, they do some optimization. And also another optimization. Then only they generate the code 1100, 1100, and 0010. Then only it will have this code. Then it's stored into this. When computer can read this, it will run the instruction. So these are all for the chapter number 2. So don't worry, later I will show you some of the real life example of the machine code. Not machine code, assembly code first. Machine code I will also show you, but we want to know the assembly code because machine code is all a bunch of 1 and zeros. Without some understanding of the assembly code, you cannot see that. And also there are many varieties. So any question before I give you some rest times? Any question? Anyone? We have 15 minutes rest later. If no question, then so far so good. Yeah, Long Yao Ting. Yeah, okay. Thank you for your feedback. So we will rest for 15 minutes. We'll come back 3:10. 3:10. Yeah. So have some good lunch dinner. Yeah, lunch dinner. So uh, to refresh your mind before we continue. Yeah, later we'll see a lot of the real code. We'll see the MIPS, we'll see Intel processor, assembly codes, etc. Then you will start to think like computers. Okay. So thank you. So see you later. 3:10. Okay. I will stop my video first. Hi, good afternoon. It's already 3:10 p.m. So I believe you all have already have very good rest, right? For past 15 minutes. And the 15 minutes have just passed like this, right? Yeah. So we have to come back to our class already. So we have basically finished the lecture for the assembly uh, uh, instruction set architecture. So I already finished these lectures. Now we are going to look into the practical side of the instruction set architecture. So I already discovered some of the very important information on the website. Then you can actually have a look. Yeah. So this one I will show you one by one later. So let me go and show you the first one. So this is actually, what is this? Okay. This is actually the assembly code for the X0, X66. Okay. So as you can see, there are many instructions here. Yeah. So let me see how I enlarge it. Okay, as you can see here, for all the instruction, actually, they will, so for all the assembly program, basically we have different sections. The first section is actually the section is labeled with the section. So this is the assembly code. Section dot data means that this portion is for you to store the data. So we have the hello. Hello is one of the data defined as byte. Database in byte. Then you have the single quote here at the beginning and the single quote at the end. So basically, you just write hello world. And then you have the comma 10. 10 is actually the ASCII code. And then 0 is also ASCII code. So 10 and 0 is to say that this sentence end after hello world and go to the next line. Okay, 10 is the next line. It's actually not 10. Sorry, this is not a 10. This is basically 10 in hexadecimals, 0 here. And then we have the second section is section.text. Okay, let's observe this one. Move EX, comma, hello. So basically this command, this instruction actually moves the address of the hello into the EAX. Okay, so let's start again. Let me start again. Okay, now it's a clean one. Now I have the data here, and inside memory I have nothing. Okay, inside memory I have nothing. Now I go and assembler it. Now I can see I have many registers here. I have EAX, EBX, ECX, and EDX. All these four are actually the general purpose registers. My purpose is to copy the 0 here, EX here, with the address of hello, yeah, from the memory. So this is my memory content. Let me show you the memory content. At the beginning, there's nothing here. Okay, there's nothing inside the memory. So this is the memory. Memory means it's the RAM, RAM in this case. The RAM is here. So the EPP is the base pointer, and stack pointer is both at the 256. That's the 256 later. So now we have a hello world. We want to do until here. So what we do is to start. Okay, start, and then I port it. So EAX, where's my EX? Okay, now let's go. So you can see the EIP instruction pointer is pointing to starting to go already. Yeah. Okay. Okay, let's go and see. Where is it? Okay. EAX already done. This EAX, but it's too fast already. I cannot see. Continue. Wait. So you can see the instruction pointer is always moving. 12, 13, 14. Okay. So you can see when we run the instruction, basically the memory content and register content actually moving. Okay. Yeah. This is how to do the assembly language. So move EAX hello. Basically, they move the EAX hello address into EAX here. Then after that, interrupt to will actually print the string EAX. So they print the string EAX here, hello world over here. So yeah, let me show you. Yeah, so this is how they do. Now let's move to here. Okay, so we have the EAX, comma hello, then interrupt to. Interrupt to means you print the string. Okay, when you interrupt to, you print the string EAX. Then push 5. What's the meaning of push 5? You push the 5 into the ESP stack pointer. Okay, you push 5. Let me push 5. So the 5 is pushed over here. Then okay, this is how it works. After they call the factorial, this is a call routine function. Then after that, you call the factorial, enter. What's the meaning of enter? Enter means you are starting to use the stack. Means you want to start to use the stack. Then you compare EBP plus 8, comma 1. So may I know what is this one, addressing mode? Can you tell me what is this addressing mode? Anyone? It's okay, let me it's register plus 8, right? Yeah, go to see this one. Let us go to this addressing mode. Which one? Anyone can see which one? Here the EBP is register plus 8. EBP register plus 8. Over here, right? Around here is a displacement, right? But for the base register. So it's a displacement here. And what is this mode? Can anyone tell me what is this mode? 1. Which one? Anyone? 1 is which one? Anyone can answer? It's immediate, right? Immediate, huh? Okay. So it's immediate for the constant. Yeah. So there are many instructions here. Okay. So you can have a look. I will give you this file of the example. Let me move on. This is the X0x86. Yeah, I believe some of you are very interested to do this assembly language, right? Because I'm very interested to know all about this, because even though I know how to use computer, but if I don't know all this assembly code, I cannot understand the basic, right? Yeah. And then it has the integer multiplication, you have to call, push, etc. So we'll learn about this later on when we have time. So this is how to print a text for the assembly language. So this HLT is a hot. Okay, so this is an Intel. Now I go and show you the X0X0. For the X0X0, basically it's also an Intel processor, but it's not compatible with X0X86. Okay, what it means is the instruction is different. So I'm going to show you the simulation project on the website. Okay, not this. I want to directly show a simulation. Yeah, live version. So later I will give you all this link. You can have a look. Yeah, so I will use some code sample. Yeah, set. Okay, so this is actually the X0X0. As you can see, we don't have the AX, BX. For X0X0, they just say A, B, C, D, E. Yeah, so they just run like this. For Intel also, same Intel, but the instruction different. It's not compatible. So they have the log, LD, AX, DC, all these instructions you have to see yourself. Move the A. Yeah. So let me start to run and show you. Yeah. When you run, then you will show the result there, so you can have a look later. Besides, we also have the 8-bit X0, X66. 8-bit. Okay. 8-bit means it does not have the 16-bit. Yeah, it's the first one. First Intel computers. Okay, you can see this is the 8-bit. You will never see AHBL. Why? Because it has no high and low. It only has the 8-bit. It's an 8-bit processor, born 1978. Yeah, so I will run a little bit to let you to see the RAM and register. This is jump not 0, compare, increment, move. Okay, all these instructions. Okay, so you can see the memory has been changed using all these instructions. Yeah, hot. At the end, you will have to be hot. Yeah. So, and then also I want to show you the MIPS processor. Yeah, MIPS processor is also very powerful. Yeah, powerful. You can download it from here, MIPS processor. Now, where's the MIPS processor? Let me see whether I have installed it. MIPS, Qt Spin, MIPS. Yeah. Let me show you what is a MIPS. MIPS is actually having three operands for each of their instructions. So I will show you this MIPS as well, so that you understand that in this world, that not only Intel processor, there are many other types of processors. Yeah, just that Intel is a most successful one. Okay, this is a MIPS. When you program MIPS, all these are the MIPS instructions, so you can run and etc. You can run. Then it will show you, where's it? Any problem? Okay, let me open the file first. Load file. Then hello world. Okay, and then I run. Hello world is shown. Why every program have to show the hello world? Because this is the culture of the programmers. Yeah, every programming language, they must create their first program to show the hello world. Because when a baby is born, basically they see the world. So the program is born, right? The first program, they say hello world, like that. But all the program also got one program like this, hello world, including C, everything. So for the MIPS processor, you always see there are three operands, one opcode, 3 operands. Basically, there are many register here, 32. 32 is register here. Yeah. So the interrupt is done using system call for the MIPS processor. If you're really interested, you can actually read the manual, and then you can do a lot of things about the assembly language. It's very interesting, basically. Yeah. Because if you don't know assembly language, you really cannot many things you cannot do. Like you want to fix computer, you don't know assembly language, you cannot do. Yeah. Okay, let me copy this link to you. You can actually, these are the links on the website. Yeah, so I will paste it here. I hope you will be able to learn a lot of computer language. Yeah, so you can actually get all the examples here and then try to learn yourself. Then you will know we have a lot of different type of computers. So now, let me go to the tutorial. Yeah, we have learned a lot of things. So today we will do a little bit about the tutorials. Tutorials 2. Let's see whether you can understand my lecture or not. Yeah, we will do 1 or 2 questions for today. Okay, let's do which one? Let's do this. Tutorial 2. Now we are going to do this question. Given the following memory values and one address machine with accumulator. Now they are talking about one accumulator architecture. What 20 contain 40? What 30 contain 50? What 40 contain 60? What 50 contain 70? What value do the following instruction load into accumulator? Now, let's do this exercise. I'm going to create a Jamboard for you. Jamboard. Where is the Jamboard? Yeah, I'm going to create a Jamboard. Everyone please join this Jamboard. And later you please write your answer to the Jamboard. Need access, everyone can access, yeah. Edit, yeah, everyone can do editing. So please join the Jamboard and then you can write your answer here so that I can see your answer. Answering this 1A. Okay, I'm going to use another computer because once when I show this, I cannot see other things here. Okay, given the following memory values and one address machine with an accumulator, what value do the following instruction load in the accumulator? Please write to the Jamboard. Load immediate 20. Load immediate 20. This is very, very tricky. Yeah? Load immediate 20. Yeah, guess what is the answer?
40.
40. Immediate or immediate addressing mode? Immediate. Not immediate. What is inside accumulator?
Okay. So the word 20 is referring as the register, right?
Yeah, 20 or you see immediate 20. That means that only have one accumulator. Load immediate. Immediate means is this number. Load immediate. Yeah. Chungi, what can you get? Immediate.
20?
Yes. Yeah, 20. Yeah, let's see. Let's start. Yeah, immediate. I have the answer, so don't worry. Yeah, 20. Yeah, very good. Please give a big round of applause to Chung Yi. Very good. 20. Because immediate means you immediately load the data. Yeah, very good. Yeah, let's give a big round of applause to Chung Yi. Very good. Okay, second question. This one no need Jamboard. Load direct. What is direct? When we say we load direct means we go to the direct. Direct means direct into memory. Load direct the content of the memory. What do you get? Memory content is like this. Let's do on the Jamboard also can really turn on their mic. Any other besides Chung Yi? Because we want to give the other to speak up also. Anyone can turn on your mic. Yeah. What's the answer? Anyone? Direct means memory. Yeah. Chung Yi just say 40. Yeah, correct. Give a big report to Chung Yi. Yeah, correct. The answer for when you say direct is direct into the memory. Okay, so it's 40. Let's confirm with the answers. Let me scroll a little bit. 40, yeah, very good. Very good to me. Okay, next. Next one. Okay, next one. Look, indirect. What is indirect? What is indirect? Go and search. What is indirect? Where's indirect? You cannot see. Is it register or memory? Should be memory indirect, right? Indirect. Yeah, this one means it's like this. Indirect. You go to register. Memory indirect. Indirect. Yeah, you go to this one and then 20 indirect. So what do you get for indirect? Guess. Chung Yi also can answer if you want. For others, others take some chance for others to do. Indirect means you get after that you also have to point to another address 2 times. Who can answer? So that means you 20, go to 20, see a value, then from that value you point to another address. This one is indirect. Anyone? Who else is inside the room? Let me call name. Paul Jingwen. Yeah, Paul Jingwen, can you answer this question? Jingwen, are you in?
Yes, sir, yes.
What is the answer? Don't be shy.
For C, right? Just to me.
C, yeah, correct. Indirect memory, after that another memory.
60.
Yeah, correct. Very good. Please get your rapport to you. Okay, very good. Yeah. Okay, don't be shy. Yeah, very good. The answer is 60 because you point to here, indirect, you point to the memory and then another memory. Means you 20, you go to search 40, then from 40, you get 60. Okay, very good. So next one. Log immediately. This one very simple, right? What do you get? 60 here, correct. Yeah, immediate 30. You want me to call a name or you want to answer yourself, surrender yourself?
Just call the name.
Who has oh, just 30, I think he said, okay, good, very good. Okay, thank you. So, not indirect 30. Indirect 30. You cannot see that now. Indirect 30. Yeah, how about indirect 30? Sorry, not direct 30. Which one? Direct, now direct.
50.
50, yeah, genuine, very good. Yeah, correct, very good. Okay, last one, F, go indirect 30. Go indirect 30.
70.
70, yeah. It's Long Yao Ting, is it? Okay, very good. I see the symbol is Long Yao Ting, right? Okay, 70, very good. So that means all of you know how to differentiate between the immediate is just number, direct is the memory, and then indirect is memory to the memory, right? Yeah. Okay, now you can do very good. Now we do the 2. Let's see how far we can go. Okay, let the address stored in the program counter PC be designed by the symbol X1. Okay, symbol X1. The instruction stored in X1 has an address path. X2, operand reference. Instruction set stored in X1 has an address path. X2. Okay, symbol X1. Okay, the store in X1. So the operand needed to execute the instruction is stored in memory word with address X3. Wow, very deep. An index register contains the value X4. Okay. Wow. What is the relationship between these various quantities? If the addressing mode of the instruction is direct, indirect, PC relative, and index. Wow. So let's do this. Spend some time to think about this. Yeah. So your program counter designated for the symbol X1. Then after that, the instruction store as this one and this. So X3, X4. So direct means direct means which one? If direct, let me show you answer. Repeat. Just now we have the answer already. Correct. So what is the first one? Direct. Can guess or not? Guess. Which one? X1 to X4? One of them. Anyone? Okay, yeah, your thing is you. Okay, very good. Okay, now who can guess the direct is X1, X2, X3, or X4, or X5? Guess. Direct, indirect, PC relative, index. Okay, let me give you some hints first. This is quite deep. So this is the X1, X2. X1 is here. Okay, X1 is a PC. Inside the program counter, there is a portion is the address X2. Okay, X2. Yeah. So the operand execute instruction needed in the memory with X3. Here, X3. And then it has the X4. So X3 is in the direct. X3 is actually equals to X2. Okay, X2. Yeah. If direct, direct X3 is actually X2. Okay. Yeah. If indirect means X3 is equals to the bracket X2 means the something inside the X2. Yeah. Okay. So if PC related, so X3 equals to X1 plus X2 plus 1. Okay, PC relative. And then the last one is index X3 equals to X2 plus X4. Okay, so these are the answers. It's a bit difficult. So you can copy this answer first. Yeah. So any question you can ask me. Yeah. So this is the answer. Everything based on X2. Just that for direct, you just directly X2. If for indirect means it will take the X bracket of the X2 means the memory content of the X2. Okay. If let's say PC relative, why is plus 1? Because you need to go to the next instruction. Like that. So you have to plus 1. So for the index, you have to add the index which is X4. Okay, so these are some of the answers. Any question you want to ask? If not, then I will move on.
So the question didn't have any codes, but
yes,
we have to like.
Didn't have any what? Any input? No, there's no input. We just want to study about the addressing mode.
Addressing mode.
Yeah, just like this only. Yeah, addressing mode. Means a program counter is designed by the symbol X1 program counter. So this is the program counter. Then instruction stored in X1 has an address part, operand reference of X2. Okay, so if so after that is this X3 is here. So that means if direct means we directly have the memory address here. If let's say indirect means you have to go and find the other places for the this address. Then if PC relative, then you have to plus 1. Okay, X1 plus X2 plus 1. So if X3 index means X3 is X2 plus X2, X4, sorry, X2 plus X4. Yeah. So like this. Let me explain again. So here, if direct means this operand is directly go into this X3 memory. Okay, this is the first direct. If indirect, then X2 have to go and find the memory location, then only is stored into X3. The third one, PC relative means is another is order, so you have to add to this X2, add another one. So this is the PC relative. For index, so this X2 have to go and find the index value of X4. Then only it will be stored at the X3. So everything at the end will store in this X3. Yeah. Can you understand what I mean? Yeah. Okay, if okay, then we will move on. Okay, now very difficult already. This one. An address field in an instruction contains decimal value 14. This is address field. Where is the corresponding operand located for immediate addressing? Where is the immediate addressing? Okay, let me show you answer. This is for opcode. It has 14 decimal value 14. So where is the corresponding operand located for immediate addressing? So immediate means 14 here. The address field, you put the 14 here. Okay, so direct addressing is a memory location 14. Okay, if indirect addressing, the memory location whose address is in memory location 14. Okay, if register addressing means registered 14. Okay, the meaning is like this. Let me explain again. Okay, an address field in an instruction contains decimal value 14. So you put 14 here. If it is immediate addressing, we just put 14 here. Okay. If let's say it's a direct addressing, the value here is not 14 anymore. The value here represents a memory location with the address 14. Okay. If indirect, so this 14, we go and find the memory location 14, go and find a value, then go and to another place and then find the another value. Let me explain a little bit. Let me show you the whiteboard. It takes me 2 minutes to open this whiteboard. Yeah, I'm going to explain a little bit more later. Okay, yeah, my whiteboard started already. So you can see for this instruction, for example, let's say this one is, which one is my pen? Yeah, let me use a blue color better. Okay, the opcode is move 14. Okay, yeah. But let's say if is the addressing mode is immediate. For example, let's say this is immediate, meaning that the value here is 14. Okay, means this value represents 14 for immediate. Let's say if it's not immediate, it's direct addressing. So this 14 will go and find the memory. Okay, memory. Okay, so here we have the 14. This has a value there. Maybe this value is 20. Okay, 20. So this 20 will be substituting this 14. Okay, the thing that will be processed is 20, not 14. If indirect, let's say third one, indirect, 14, go to see the 14. Then the 20 is here. What happens is at here in the memory content is another memory content is 20. So this one may be 5. Okay. For the B, 20 will go here. But for the C, the 5 will go to this value and substitute the whole thing. And then this will be processed. The 5 will be processed instead of the 14. So this was C. Okay. So the last one, for register addressing, let's say got a register, the name is 14, register 14. So this 14 will represent the value here, let's say is 6. So the 6 will be put here instead. So this is 14. Okay, We have the register, memory, etc. Can you understand? Since it goes to other the previous questions. Same thing. Let's say if the move 14, depending on the different addressing mode, it will have different values there. Yeah. Depends on what 14 represents. So this move, maybe this move in the machine code that will tell you this move is for the immediate, then you will execute directly this 14. If they say direct different instruction, then you will have different one. Okay, yeah. Can you understand, Chung Yi? Have I explained? Okay, explanation okay now.
Kind of confused at the register addressing party.
Oh, register addressing. Okay, let's say here is 14. Means that is a register 14. That means there's a register called 14. 14. Yeah. Can or not?
Okay.
Yeah. How about Jingwen? Jingwen can understand or not?
Can.
Okay, so thank you. So previously all this also same. The two one are indirect. All this one same. PC relative is something new Okay. Very very fun. Okay, direct addressing mode. All this addressing mode. So we have done 3 questions today. I think your brain is a bit saturated now already, right? I think we will stop here to let you to ask any question you will have. Any question you have for today's lecture? If you have any question, let me know. Chung Yi or Yao Ting? Yeah, Yao Ting? Jingwen? So far so good. Okay, good. So for the next class, we will, on this Friday, we will try to do more exercises so that you understand the difference between immediate, direct, indirect, also index. Yeah. So far so good. So any question you want to ask me before we end the class? So Xu Bian. Yeah, Chan Shipian. So for the assignment, the other processor need to mention in chapter 3 discussion and comparison. Only or chapter 1 also. Yeah, I have to mention for chapter 3 also. Yeah. It's just like Intel. Yeah. Yes. Same thing. Any other question?
So we just choose one product model or a product line of a company brand that have the, for example, Intel, i7,
for example,
and versus AMD, ASUS, blah blah blah, something like
that. Just one model enough Let's say i7. Of course, i7 got many models, but you choose the ARM version 10 enough No need to be so specific Yeah.
Oh, just a line.
The line only i7.
Okay.
And then for it's maybe version, how many version enough Then you go and search the data. Yeah.
Okay. So any processor will do, right? Like the CPU or GPU or like something like that.
GPU also accepted GPU also accepted. Yeah. Accepted.
Okay.
SC is not a CPU. SC is a design method FPGA also design method. Yeah. So that one is no architecture, so we cannot discuss Anything with the architecture can discuss. Yeah.
All right.
Okay. So who has 3 members in your group? Because I believe we have 31 students. Any group with 3 students? Never mind, if later you can't find, the last one cannot find, you can join any group. Yeah. So if you have any problem, you can let me know. How about the timetable? Are you okay with the timetable or not? Okay, right? Chung Yi, are you okay?
Timetable?
Timetable, okay, right? No pressure.
You mean the timetable for the
Yeah.
class or the due date?
For our class. For our class and assignment, okay or
For
not?
class is okay lah. Assignment, I'm not sure.
Okay.
We don't have the
Oh,
practice,
okay.
right?
We don't have the lab session, yeah. We don't have the lab session. So, yeah. Any other problem you face during the class? You can let me know lah. Yeah. If no question, then you are allowed to leave. So I will mark your attendance. So you face any problem, for example, you have any problem to attend class, whatever, you let me know lah. Yeah. So any problem, just let me know lah. Yeah. So chapter 1 intro and chapter history also need to talk about other processor. Yes, correct. Yeah, you're right. That means that 2 person, that's the job is totally equal. Just that one do i7, one do ARM like that. Yeah, totally equal. Yeah, so you just can split directly. You do i7, you do ARM like that.
So it's like we separate the two tasks as an individual part.
Yeah. So can equally split the job.
So the task 1 have like chapter 1 to 5, and task 2 also have the chapter 1 to 5, is it? Or we have to combine all chapter together?
Combine. Because the marks will be combined.
Correct.
Marks will be combined. You can help each other. There's no such thing like different marks. Yeah, it's the same marks unless really don't do work, you let me know. Yeah, but marks usually will be same. Because you help each other, right?
Thank you.
Yeah. Okay, thank you. So if no problem, then you may leave the class. Now it's 3:58. So hope you okay, you can study a little bit lah. So and if you have question, you can let me know. That's all. So thank you very much, and see you on Friday. So happy holiday on Thursday lah. Okay, bye. Okay, I will stop here. Thank you.